And welcome to episode 2 of Running with Science. What I'm going to do in this one is tell you how to calculate your critical speed and your lactate threshold, which will enable you to set your zones using the 3-zone system that I talked about in episode 1. The 3-zone system is based upon 2 thresholds. The first threshold is between zone 2 and zone 3, and that's known as your critical speed. This is the point at which you transition from aerobic into anaerobic exercise. If you go above your critical speed, you start exercising anaerobically, and it becomes very difficult to maintain that speed. The other threshold is between zone 1 and zone 2, and that is your lactate threshold, and we will discuss the lactate threshold after talking about critical speed, because you need your critical speed in order to calculate your lactate threshold. So we're going to start by discussing how do you calculate your critical speed. Well, what you need to calculate your critical speed is your fastest time for a 5K and your fastest time for 400 meters. These should be recent relevant times, i.e. not from ages ago. They need to be indicative of your current fitness level. The studies that I've been talking about and other similar studies have tended to use a 16-week window. I wouldn't worry too much about making sure it's definitely within 16 weeks. If you haven't run a really fast K for 16 weeks, but you did run one 18 weeks ago, I'm sure it'd be absolutely fine to use that. It's probably better that you use an older, properly accurate fast K time than a more recent, slower one. You also need to take into account any gradient impacts that might have affected your fastest time. So if you ran your fastest 5K time on a bit of a hilly route, you can actually adjust your time to a faster time by using the mean gradient adjusted pace for your run. So if your mean gradient adjusted pace was 4 seconds a kilometer faster than your actual pace, then you could probably take 20 seconds off your time. So you want to take into account gradient. What I did for mine was actually use, luckily my fastest 5K and fastest 400 meters were both on flat routes. So if you do it on a completely flat route, then you're absolutely fine. But if you did it on a hilly route, then you can actually make your time a bit faster. If you manage to find a nice downhill 5K, then I'm afraid you've got to go the other way and adjust your time to make it slower to take into account you ran downhill. But you should be able to do that using gradient adjusted pace that you can get on Strava. Okay, so now we're on to the maths. So how do we go about calculating your critical speed? Well, the first thing you want to do is subtract your 400 meter time in seconds from your 5K time in seconds. So for me, my 2 times were 21:28 for my 5K and 85 seconds for my 400 meters. So if I take 85 seconds away from 21 minutes and 28 seconds, when that's been converted into seconds, which is 1,288 seconds, I get a value of 1,203. What you then do is divide that difference in time between your 5K and your 400 meter pace, which for me was 1,203 seconds. You divide it by the difference in the distance between those two distances. So the difference between 5K and 400 meters is 4,600 meters. So you take 4,600 meters and you divide it by the time difference. So my time difference is 1,203. I divide 4,600 by 1,203. You always use 4,600 if you're using a 400 and a 5K time. So the value for me comes out at 3.824. What does this mean? Well, this is my critical speed in meters per second. Okay. So this means if I'm ever running faster than 3.824 meters per second, I'm exceeding my critical speed and I'm likely to be running aerobically. Now, as runners, we're not normally used to dealing with speeds. We're actually more used to dealing with paces. And it's relatively straightforward to convert that speed into a pace. I work in kilometers. If I want to convert that speed into a pace in kilometers, what you do is take the distance. So a kilometer is 1,000 meters. So you take 1,000 and you divide it by your critical speed. That tells you how long it will take you to run that kilometer. So I took 1,000 and I divided it by 3.824, my critical speed. I ended up with a value of 262. I would round that value to the nearest whole number because we're talking about seconds. This is your pace in seconds for a kilometer that you would do if you're running at your critical speed. You can then convert this to minutes and seconds. So to convert 262 seconds to minutes and seconds, 262 seconds is 4 minutes and 22 seconds. The easiest way to do that is divide the number by 60 and use the nearest whole number that works, and then add the number of seconds you got left over. So this means I've now got a pace. My critical speed occurs when I'm running at 4-minute 22-second kilometers. If I'm running faster than that, I'm above my critical speed and I'm running anaerobically. If you work in miles rather than kilometers and you want to get your pace in miles, instead of dividing 1,000 by your critical speed, you divide 1,609 by your critical speed. So for me, 1,609 divided by my critical speed, which we calculated as 3.824, that gives a value of 421. If we convert 421 into minutes and seconds, we get 7 minutes and 1 second. So my pace, my critical speed means I would be running 7-minute 1 second miles at my critical speed. Okay, so there we go. We've got your critical speed worked out. That pace, 4:22 or 7 minutes and 1 second, that is your transition from zone 2 into zone 3. Anything faster than 4:22 for me, I'm up into zone 3, which, as we heard in the last talk, is the bad zone that we really, really want to avoid. So how do you calculate your lactate threshold? So this is the Z1, Z2 boundary. Well, it's incredibly easy. All you do is take your critical speed in seconds. So previously, I had calculated my critical speed in seconds as 262. And you divide it by 0.823. That is because your lactate threshold tends to occur at 82.3% of your speed for your critical speed. So for me, I get a value of 318. So this means that my lactate threshold is likely to be at a pace of 518 kilometers. If you prefer to work in miles, then you would take whichever value you use for miles. So for me, it'd be 421. It'd be 421 divided by 0.823. And that will give you a pace in miles. So for me, I work in kilometers. My zone 1 is anything slower than 518 kilometer pace. My zone 2 is from 518 to 422 kilometer pace, and my zone 3 is anything that's faster than 422 kilometer pace. This means that if I want to run a fast marathon, I should try as much as possible to do training at a pace no faster than 5:18. And that 5:18 pace is the value that I really should be looking at to try and stick to the 80-20 rule. I want to do 80% of all of my running at a pace of no faster than 5:18 kilometers. And what I really need to avoid doing, because zone 3 we saw was really bad, is ever running faster than 4:22. Obviously, you're going to be doing other races and things where you're likely to be doing this. So this is really about when you're training. And what I'm currently trying to do is not do any of my training faster than 5:18 pace. And it is working extremely well for me at the moment. I've run a course park run PB on my last 10 park runs, and in my last 3 10Ks, I've run a new PB each time and got it faster and faster and faster. So I've been doing this for about 4 months, and it is working an absolute treat. Remember that these values will not be exact. You probably want to make adjustments if you run a faster 5K or a faster 400 meters, or if you think your current ones are getting out of date and actually you might have slowed down, you maybe want to find another time or do another 5K, do a park run reasonably hard and see what you get. So I would recommend regularly adjusting or recalculating what your critical speed and lactate thresholds are, because hopefully they'll be improving and you'll be able to train at a faster and faster pace, as I'm finding at the moment, without exceeding zone 1. Okay, so I hope that was helpful and informative, and you managed to calculate your critical speeds and your lactate thresholds. Okay, cheers.